Okay, so today we're talking about completing the square. There, I've done it. That's all you got to know. Okay, maybe that's not actually it. Completing the square actually is if you take something like this, y equals 3x squared plus 2x plus 7. Do you agree that's in general form? Okay, and if I wrote it like this, y equals, let's say, 2 times x minus 4 squared plus 12, that wouldn't be general form anymore. That would be what? Vertex form. To get this form, vertex form, sometimes you need to do what's called completing the square. All right, so what is a square then, first of all? Well, a square is something like 25. Do you get 25 as a square? Because something times something that's exactly the same will equal it. Then it's called a perfect square. Another way to think of it is it's a square that would have sides that are 5 and 5. Right? Well, what if it was like 24? Yes, I can make 24 with two things being multiplied, but not two things that are exactly the same being multiplied. Get what I'm saying? Like I can do 6 times 4, but I can't do like, I could do actually 4.8 times 4.8, but that's kind of cheating. You have to have whole numbers to make it work. All right, same idea. What is a perfect square when it comes to one of these? What number should I put there to make this a perfect square? Ooh, you know. 9, you're right. Now, how do I know it's a perfect square? Does it look square to you, like it's a squarish shape? No. But it's because you can make two things that are exactly the same, then multiply to that. X and plus 3 and plus 3 will actually multiply out to this. There is a quadratic that's called a perfect square. Why? Because it has two factors that are exactly the same. Do you get that? All right, then just answer this for me. Don't say it, write it on your screen. Fill in the box with what would be the perfect number right there. And then would you hold it up so I can see if you're doing it right? You are correct. Yup. Good. Can't see. Okay, good. All right, I'm seeing lots of right. Oh, nope, that one's not. Check his. Mr. S, you're right. Good. All right. You do half of this and square it. Some of you forgot to take it in half first. So half of that is 6, and then squared is 36. So half and square. It always sounded to me like the name of a little German boy. Half and square. So, half and square, come and get your pudding. So, if you had this, I'm going to be referring to a little half and square more than once. So, if this is my problem, I would start with what's half of 10, and then I square it. So I'd go like 20 of this, 25. Then I've made it a perfect square. But the problem arises when this isn't 25. What if it's like 10? Then you have to force it to be 25. All right, so let me show you how I would have taught this. Now, I don't know how the teacher taught it, but did he just play my video for you? Okay, all right, so he actually taught it to you? All right, so here's how I would have taught it to you. I would have gone back and said this. Do you agree that 5 is equal to 5? Okay. Do you agree that if I add 1 over on this side, that it's not true anymore? But if I subtracted 1 also, if I added 1 and then subtracted 1, do you get that that would be the same then? I'm back to a true statement of 5 is still equal to 5. So if I add 1, I just have to subtract 1 to undo it. It's kind of like if you say a nasty thing to your sister, you really ought to say something nice to kind of counteract it. Okay? Actually, they say, though, that it takes 5 positive things to undo 1 negative thing. And I think you'll find that's true. Has your friend ever said something really nasty to you? And if your friend says something really nasty to you, it takes quite a while, quite a few positive things from that friend before you're feeling okay again. Well, in math, though, it's just simple. If you make 1 plus 1, then you got to have a minus 1 to cancel it. All right, so back to here. If I want to make this not be a 10, I'm going to move my 10 over there. And it's still there, but I'm going to add in the perfect number right here, which little happen square tells me is 5 squared is 25. And if I do a plus 25, do you get how I have to do a minus 25 to cancel that out? All right. Now, here's the key. Every problem you start, you should just push the end number over, put a plus a line and a minus a line, and those two numbers need to cancel each other out. And that number you pick is HAHon square's number. Half of 10 is 5 squares, 25, 35. And now, do you agree that I really, by adding 25 and then subtracting 25, haven't changed my equation's value? It's still the same size as it used to be. Okay, so I'm allowed to do this. Just like timesing by 1 is okay. And you can times things by 1 and it doesn't change its value. All right. Now, why did I do it? Because now this is my perfect square. And that is my leftovers. And my perfect square is going to be x plus 5 and x plus 5. And my leftovers is going to be these guys put together is going to be negative 15. And when I put it all together, the x plus 5 and the x becomes squared because it's the same thing, minus 15, and voila, I now have it in what form? Vertex form. And remember, the vertex should jump out at you as negative 5 comma negative 15. All right. I'm just going to pause for a second here. Back to this. All right, here we go. Here is another problem that is typical. Y equals 4x squared plus 12. No, let's not make it 12. Let's make it 16x minus 5. And that is not possible for you right now. And I want you to tell me what's different about this one that makes it not the same as all the others that you did. Yes? There's a 4 in the front. Why is that not good? It complicates things a lot. Yes, it's not factored is another way to say it. Yes. All right, so I'm going to teach you how to solve that kind. But first we need to conquer some other little problems that come up. How about this one? What's not nice about this one? X squared plus 3x minus 7. Half of 3 is kind of a pain in the butt. Yep. I'm going to show you how to handle that. Everybody write this one down, please. All right, here's what you do when half in the square is not going to work out so nice. I'm still just going to move that negative 7 over. So if I had an eraser on my iPad, I would use it, and I'd move a minus 7 over there, and I'd put a plus a blank and a minus a blank. You always put them in that part. This is all the same as it was. It's just this new part right here. Okay, and then half and square is going to work, but you have to do it creatively. What's half of 3? Yeah, you could say 1.5, but what happens when it's half of 27.6? It's going to be a real pain in the neck sometimes. So, you use this. How do I say half of something? Divided by 2. So how do I do half of 3? I go 3 divided by 2. And then that's half, and then half and what's the other part of the guy's name? Square. So I square it. So there's half and there's squared. Get what I just did there? Do you get that dividing something by 2 takes half of it? That's why that's the half part. And then here's the squared part. All right. Now, 3 over 2 squared is actually 9 over 4. Do you get that? So then I'm going to just use 9 over 4 over here. Since they're the same exact thing, I can use one in one place and the other in the other place. And why would I want to use that? Because when I do this part, and I want to make these exactly the same, I say x and plus and plus. What number do you think goes in here? No, not the squared part. Just the 3 over 2. You see how that came in handy? All right. The reason I'm showing you this is that you got to be able to handle things like this. What if it's y equals x squared plus ax? Now you try to get half of a. What's half of a? A over 2. So if I'm going to fill in this blank here and say plus, what would be my magic number? It would be a over 2 squared. See how you couldn't do that unless you knew that technique? And what's that the same as? A squared over That's the same as a squared over. Now, wait a minute. I just added something and then didn't subtract it. Is that okay? No. So I'd have to have plus that and then minus a squared over 4, which makes up for the fact that I added a squared over, or a over 2 squared. Nope, because I got one that's positive and I got one that's negative. Now cancel each other out. There wasn't a third. So my final answer for this one would be y equals, wait a minute, first I should make two sets of parentheses here. Do you get that I was trying to make a perfect square where they're exactly the same? X, and plus, and what would it be? A over 2. And then, what's at the end? My leftovers is that thing. Minus a squared over 4. Could you say it this way? A over 2 squared? Yep, I'd be okay with that. All right, so back to this kind of problem. Let's see if you can hang with this one. Ready? Get on a blank page. I don't trust some of you right now. Get to a blank page. All right, ready? Y equals x squared plus 5x, and I'm just going to leave it. I'm going to say plus 0 at the end, or just x squared plus 5x. Figure out what the answer is. Yep, this is in general form, and what I'm really asking you to do right now is write this in vertex form. So basically, complete the square. First job, plus a line, minus a line. Do this. Do this. Next job. Who tells me the answer on this one? The little German boy. HAHon squared. Half of 5, 5 over 2. Squared. Squared. And then you can actually do that. 5 squared is 25. 2 squared is 4. 25 fourths. Final answer. This part needs to be perfect. X, and plus, and what do I use? 5 over 2. And then what's my leftovers? That thing. So y equals x plus 5 halves squared, that's just putting this and this together, minus 25 fourths. Hardcore math. All right. Do you see that your answer is a couple of fractions? If your vertex would be negative 5 halves and negative 25 fourths. See how vicious and difficult that one is? All right. But they get tougher than that. All right. Here's the kind that you're going to have to be able to handle now. What if it's 3x squared plus 6x plus 4? And I need that to become, add plus 1, plus a blank, minus a blank. It's not going to work because of that 3 up in front. You do have to do a special kind of factor. Did you know, a lot of people would say, you can't factor anything out of this because there's nothing in common. You're right, kind of. But did you know you could do this? You can just factor these two. It is allowed. 3 comes out of there, and what would I have left? X squared plus 2x, and then I just leave the plus 4 at the end, outside, left out in the cold. Do you get that if I multiplied this out, that I'd get this? So. All right. Now, is it done yet? No. This is the part right here that needs to become a perfect square. So then I got to do my at plus a blank and minus a blank. Where in the heck am I going to put those things? Well, you need the plus a line right there. And do you get that I need to do minus a line outside over here? I'm going to move my plus 4 all the way over. I like to do it that way. You don't have to. I'm going to put my minus a line there. So now I've got my special hero comes in to save the day, plus a line and the minus the line. And what should I put there? The little German boy helps out. Half and square. Half of 2 is 1, and then I got to square it, though. And it's still 1. Good. Now here is the part where I want to see if any smart kid can figure out why the problem as it is written right now is not correct and is not okay because it is not balanced like it used to be. In the back corner. The outside numbers do not have to add up to 4. Thank you for trying, but that's not what I was looking for. What do you think? Another set of parentheses wouldn't be enough to solve my problem. What do you think? You got it. This number right here is not really a 1. Do you get how that 3 is going to get multiplied by that 1? Which is kind of what you were getting at with the parentheses thing. But I can't fix it by parentheses, but I could fix it by saying this. Do you get that I'm going to go 3 times this 1, and that'll make 3? So I need the other one to counteract it to be negative 3. So I got to multiply this one by 1. 3 times this one and 3, so that way this one's getting multiplied by 3, and that one's also getting multiplied by 3. 3 times the 1 would make 3. This 3 times that would make negative 3. Then they'll cancel each other out again. So here's the extra step people always forget. You have to put whatever number you factored out here, you have to put it right there because you're trying to get this blank and this blank to cancel each other out. And if I don't put in a 3 right there, 3 times whatever's there, it won't work. Because I'm timesing by 3 in front of this, I got to times by 3 in front of that. Let me finish this one then. This part right here was the special part that gives me the perfect square part. X plus 1 and x plus 1. There's still a 3 out in front. It's called the stretch factor. And then there's this negative 3 plus 4, which makes positive 1 leftovers. And then my final answer, x plus 1 squared plus 1. Does that look like vertex form, except it's been stretched by 3? That's the new stuff for today. There was a negative 3 right here. Get it's 3 times negative 1 makes negative 3. But then there was a plus 4. What's negative 3 and plus 4 make? Positive 1. All right. I know these are difficult, but stay with me. You're in an accelerated math class. You're supposed to be pretty smart. Okay? I think you can handle this if you stay with me. But it's getting to that part of the hour where people tend to drift. Okay, let's do one more question first. This one right here has to be a certain thing based on this. Remember how it has to be half of this and then squared? That's why that's got to be a 1. All right, so now, what if I had this? Everybody, blank sheet. Blank sheet. Somebody's still staring at the screen and I'm suspicious. Blank sheet. Thank you. All right. Do that one. Give it a shot. First thing you do is factor out the 4. This 4 has to come out. Now what I have up on the board would multiply back out to be exactly what I had in the first place. So that's why it's okay. Your plus line and your minus line go like this. All right. So here's what we do. We fill in that plus box right there with half and square. Half of 2 is 1. 1 squared is 1 and 1. But if you just stop right there, what did you do wrong? You gotta, this one got times by 4, so that one has to be times by 4. Be honest, how many of you forgot that part? Only some of you forgot that part? All right. All right, so when you actually get it all done, this part right here is your perfect square part, x plus 1, x plus 1, and this part is my leftovers, and that's negative 4 plus 2 makes negative 2. And then final answer, I think I told some of you were wrong when you were actually right, is that. Raise your hand if you had that before me. All right, good job. That's more than half the class. All right. Now, tell me, I saw this 2 here and this minus 2 here, and I thought, oh, that can't be right because that's pretty much the same number. But it did have that 4 factored in. Anyway, what is the vertex now? Why are we even doing this? Because the vertex is so obvious now. It's negative 1 comma negative 2. And why is that important? Because so often in your problems in the real world, the vertex is the only thing you care about. Do you get that a parabola is made up of like an infinite number of points, but only one of them can be the very top, or only one of them can be the very bottom. And so when you're asked, how high did the ball go when he threw it from first base to second base? It makes a parabola. And how high did it go? That's the vertex. That's why the vertex is so important. That's why we spend time doing this thing called completing the square to help you be able to find the vertex. All right. And in the real world, would you actually do this? Probably not. You'd probably just graph it. And then you use your calculator to tell you what the vertex is, because that'll even work when the numbers are nasty decimals. Okay, but this is a way that tells you the vertex, and at least understand this. Don't deny it, but the vertex is an important point. It's because there's only one of them, and there's infinite number of other types of points. Okay? All right. So now, your homework for today. I want you to find it right now. We'll do the first couple of problems together. I am going to allow you to have a smaller assignment than normal because we had to spend so much time with the catch-up kind of stuff. We are also going to have to stop working in like 1 minute because I got to give you your old test back. And so your assignment, we're going to shrink. It is worksheet B. It's called, is it 7.2 or 7.3B? 7.3B, okay. So you're doing worksheet 7.3B, and for your class, I'm going to ask you guys to just do the odds, okay? Don't destroy the evens. We may come back to them and do some of them in class as in-class examples. And if you ever wanted to use something to practice for the next test, which by the way will be coming up in the middle of next week, you may want to be looking back at those even ones. But for right now, just do the odds. And number 1 is super simple. Don't even look at it. Let's do number 2 together. Sorry, 3. Good point. Yes, number 3. All right, Mr. S., would you read me number 3? Minus 8x. Minus 8x, and then what? Plus 6, thank you. All right. To begin with, do you get, don't pick on him because he's smart. Do you get that this 2 can be factored out of the beginning? And I know some of you are going to be tempted to factor it out of all 3 parts. Don't do it. Just factor the 2 out of these 2. So it looks kind of weird. Watch. Because that 6 has to be at the end with the leftovers. Remember how we have to put that together with the other number? So trust me, you only want to factor it out of the first 2. It's still correct. It's still going to multiply out to be what it was in the first place. And this way is better, because now I can squeeze in my plus line and my minus line. Plus a line, minus a line. And who tells me what to put there? The little German boy. Half and square. Half of 4 is 2. 2 squared is 4. 4. Then don't forget the thing that I always forget. Yep, that 2 that we pulled out to the front has to also go here. And then you can probably finish it off yourself. Go ahead and try it, and I'll tell you in like 30 seconds here what the right answer was. It starts with a 2. And it has to have something squared because that's what perfect square is. And then some of you will forget this. It's x minus 2. Because to get the middle term to be negative 4x here, you need x minus 2 and x minus 2. And then, last, I have negative 8 for this, plus 6 makes negative 2. I have it. Eureka.